Okay. Last class we have discussed about the model one within the subpart that is automotive fundamentals overview. In that, I have discussed in depth about evolution of automotive electronics and the physical configuration, and especially the concept related to engine and engine block and the four-stroke cycle concept and the engine control ignition system and circuit and distribution uh, in and somewhat the concept about the brakes, okay, and the operation principle of a battery also. Okay, so now within the module one, there is one another concept that we call treat as a subpart of the module one. That is the basic of electronic engine control. Okay, so uh, let me discuss about in depth about this basic of electronic engine control here. As I told in before in the second day class, that is it's going to match with the CO1 as a knowledge level 2. Okay, so here we're going to see in depth about motivation of electronic engine and exhaust emission, the fuel economy, and the concept of electronic engine, control system, then spark timing, ECR, control strategy, then electronic fuel control system analysis, and made for pushes and electronic ignition. Okay. So before in ignition system, we'll go with some electrical base. So now in implementation of the model one, the next subtopic that is comes under the electronic engine control. So we are going to main focus with electronic ignition rather than electrical ignition. Okay, mechanical ignition. So this is the concept, the model one. I'm going to paper with basic of electronic engine control. Okay, so before that, I'll tell you what are the concept of electronic engine control system. That says okay. So directly I'll move with my notepad. Okay, so let me see the concept of electronic engine control. Okay, so the first I'll discuss with the concept. Uh, okay, concept concept of an electronic engine control system. Electronic engine control system. Okay, so here to understand the electronic engine control, it is necessary to understand some fundamentals of the powerful produced by engine, how it is controlled, and any driver which is going to understand that the throttle directly regulates the power produced by the engine at any operating condition, and it is controlled by airflow in the engine, which is being controlled by airflow in the engine. Okay, so in a engine, it is essentially an engine is an air pump such that at any revolution per minute uh, RPM, the mass flow rate of air into engine varies directly with throttle plate rectangular position. Okay, so the mass flow rate of air in engine varies directly with the throttle plate and angular position. We call it as RPM. Okay, so any driver depress the accelerator pedalate. So, for example, this is one pedal. Okay, it's been touch up with some. Uh, then again, it's been touch up with again wheels here. So any driver is being get pedal here automatically. The accelerator pedal, the total angle it's going to be formed that is being treated in theta t. Okay, so theta t. So with respect to that figure, how it is been compressed. Okay, so for example, if I have one plate like this, okay, having some discuss here. So that is the intake. Okay, and this is a top view. Okay, again I have another one plate. Okay, so that is been aligned. Here is going to form an angle. That is, if I project with respect to the tangent, it's going to form one theta t. That is nothing but RPM. And if I exhaust with airflow here, airflow in, okay. So airflow in to engine, okay, engine. So it is nothing but this cross is nothing but pivot. Okay, so this is the diagram which intimates me the RPM. The mass flow rate of air in engine varies directly with the total plate angular position. This is nothing but this one, total plate angular position. Okay, so if I go with the total plate front view, it's showing like this. Like this. Again, it's been armed with semicircle. Okay, so it's been round up with again one semicircle. Okay, so this is a throttle plate. So this is a end view. End view. So this is a figure related to the intake system with total plate. Okay. So if we go with for more discussion with related to that, okay, here the engine power here, engine power is given in kilowatt, okay, and air mass is given in kilograms, that is kgs, and the donating power from engine denoting power from engine, that is PB, in linear model, the engine power is given by, which diagnosed in linear model, the engine power is given by PB equal to KMA. Okay, where PB is power of engine. Okay, power of engine either in horsepower or in kilowatt, capital W. Okay, and MA is nothing but mass airflow